So guys, in this example, I have two coefficients of a friction, μs and μk. And I want you guys to recognize the difference between them. Do you know what is the difference between them? What is the difference between static friction coefficient and kinetic or dynamic friction coefficient? Anyone can tell me, guys? You don't know, guys? So guys, what's the difference between static and dynamic friction coefficient? Yes, Abbas, static friction is when the object is at rest. But do you think that there is a friction? That there is a friction if this object is not moving? In fact, this is not exactly the definition. Static friction, please guys, look, take a look on this definition. It's very important. Oh. Static. Oh my God. Okay. So static friction is what keeps the box from moving, which means I'm giving the box a certain force, but I still at rest. This motion, this mass or this box is not moving because this force is not overcoming the static friction. All right. So static friction is what keeps the box from moving, while kinetic friction or dynamic friction is the force that resists the motion once it is. And what does this mean, guys? In fact, this means that if I want the motion to occur, I need to overcome what? First, I need to overcome the static friction. And this means, guys, that I need to find the time after which I overcome this static friction. So if I have a motor like this case, and this motor is doing a force to allow a motion, all right? So this motor is doing a force that push this crate, all right? In fact, there will be some time, some duration at which this motor is doing a force, is pushing this crate. However, there is no motion. So why? Because in fact, the first duration, this motion is trying to overcome, or this force, the force of this motor is trying to overcome the static friction. At a certain time t, this static friction is overcame, and then the motion starts. All right, guys? So I need to exceed this static friction. Whenever this static friction is exceeded, then the motion will start. All right? So whenever, guys, I only have μk, you don't have to worry about μs. But if you have both μs and μk, you need to find the time at which this crate starts moving. So I can have some duration at which the crate is still at rest before starting the motion. All right? So I'm gonna write it also down here. Whenever I have both static and dynamic or kinetic in the question, you have to find the time after which the motion stops. How can I find this time? We're gonna see how now. Okay, guys? So that's it. Let's duplicate it and start solving. Okay. So if I want to start, guys, by the static case. In the static case, there is no motion. So this is my crate. There is two forces from this motor. So this motor, guys, is pushing this crate with two cable forces. So there is two forces that are, of course, equal by this motor. I have a weight. I have a normal force, but I don't have an acceleration. Although I don't have any motion, I have a static frictional force. So if I want to apply this in this direction, so of course A here is equal to 0 since there is no motion. So no motion, it's statics. Then what I'm going to have is 2F minus the frictional force is mu static. Why are Fs, you mean F, directed to the right? Because the motion, this is the question, the motion is supplying a cable force so that this crate is moving, all right? So it is supplying a cable force so that this crate is moving. So it's not, it's a cable force, it's opposite to the tension, all right? So it is doing a motion. It's pushing this crate in order to move to this direction. Okay? So it's 2F minus mu S normal force is equal to 0. Now I know, guys, that the normal force is equal to the weight if you apply the equation in y direction. So the normal is equal to the weight, right? So I'm gonna replace the normal force by the weight. Is equal to 0. And then, guys, I'm going to replace this force by 60 t squared. So 120 t squared minus 0.5 times 150J. 150G is equal to 0. And this means that T is equal to 0.4. What does this mean? What is this T? Who can tell me, guys? What is this T? What is this T, in fact? So after a time of 2.4, yes, the motor force, or F, exceeds the friction force, or I don't want to say F, it's 2F in fact. So the forces exceed the static friction force, and then mass is moving. Right, guys? Okay, then what should I do? Now I am in dynamic case. All right, so I am in dynamic case. So in this case, I have the same free body diagram, except that now, what do I have, guys? I have an acceleration. So this is the frictional force. These are the motor forces. 2F. I have a normal force here. I have a weight, but I also have an acceleration. And I still have, guys, here that the normal force is equal to the weight because there is no AY. There is no AY. Which means, guys, here I have 2F minus mu dynamic, all right, mu K N is equal to M times A. So if I replace F by 60T, 120 T squared minus, what is mu K? It's 0.9, 0.4, sorry. 0.4 times the weight, which is 150 times 9.81 is equal to 158. I don't know A in fact, but now guys, I can find this A in terms of time. So what will be A? If you do the ratio here, you're gonna find that A would be equal to 0.8 T squared minus 3.924. This is A. All right? Whenever I know A, I can find V. Why? Because in fact, my question is to find the power, which is F times V. Whenever I know A, I can find V. Why, guys? Because I know from the general motion equation that A is equal to what? Chapter 12, dV over dt. And this means, guys, that dV is equal to a dt. And now I can do the integration because I know t in terms of time. Now, this integration should be between what and what? Who can tell me, guys? It's between what and what? Between 2.4. This is the time at which the motion starts moving. I cannot say it's between 0, guys, because the time at which this motion occurs is t is equal to 2.4. And they are telling me that I need to find this power at t is equal to 5. So I'm going to say this is 5. And then the velocity from rest to v. So if you do the integration, then you're going to find that this v will be equal to 0.8 t cubic over 3 minus 3.924 t between what and what? Between 2.4 and 5. If you know the substitution, v will be 19.38 meters per second. Now, whenever I know v is, I can in fact find, I can in fact find the power, because the power is the force of motor that are 2F, all right? So the force of motor, guys, is 2 cable force. So it's 2F times V. So this motor is doing 2F on this crate. So it's 2 times 60 T squared at T is equal to 5. This is the question. They want the power at T is equal to 5 times V, which is 19.38. And then you can find, guys, that this power is equal to 58.1 kilowatt. Right? Any question, guys? We're still